All right, so we're working with accelerating objects. They're changing direction, right? So that changes our setup a little bit. We've got to pay very close attention to the directions that are given in the problem, right? We've now got easts and wests. Before we didn't really have that. Things were not changing from one direction to another. We have to do one extra little step in our setup. So here a baseball is thrown 15 meters per second. Just going to underline things as I read them. And 5.6 seconds later, it's moving 21 meters per second west. A lot of information in one sentence. Like that's your entire problem right there. All the information you need. Calculate the average acceleration of the baseball. So the formula we're using didn't change, just our setup a little bit. Very important now to have your coordinate system. What are you going to write down as positive and what are you going to write down as negative values? And to be consistent, I will always use east as positive, west as negative. No, I'm good with my color scheme, thanks. So up is positive, down is negative. There's nothing changing that way. I'll just get rid of that. So as always, reread the question again, write down what you want to know, and this is what's new, make quantities relative to the positive direction. So as I write down everything, if I write down a W, I've got to change that to an E for east. So I'm going through the problem again. First thing is initial velocity is 15 meters per second. I'm going to emphasize that it's east. Right? Direction is really important now. Basically, from now to the end of the semester, direction is key. Time, 5.6 seconds. Final velocity is given as 21 meters per second west. Okay? So as you're writing down all of these quantities, if you end up writing two different directions down, we can't do the math. It's the same thing as adding 100 kilometers plus 100 meters. It's not 200 kilometer meters. You've got to have the same units. Well, in physics, we need to have relative to the same direction. So we need both of these to be east. So final velocity is rewritten as negative 21 east. Now when we work at our math, if our answer is negative, it's negative. It just means west, okay, or opposite the positive. Same formula we've been using for a while, acceleration formula, change in velocity over time. And so now let's put the values in and figure it out. So acceleration is going to equal final, which is negative 21. That's a little bit different. We didn't put a negative number in before. Subtract the initial, 15, times 5.6. So the change in velocity is negative 36 meters per second if you were to put the units in, right, in 5.6 seconds. Okay? And until you put that negative in for the west direction, you don't really realize that it's such a large change in velocity. If you forget the negative, you have 21 minus 15 and you get 6. Well, this object didn't just get changed to be changed by 6 meters per second, it changed by 36. Okay? So it's a big physics mistake when you're doing your calculations by forgetting those negative signs. So they become very important. If I'm going through one of your questions and marking it, and you forget to set up with a negative sign, that's a big deal. If you have it there and you're working through your math and it just somewhere goes away, that's not a big a problem. But you still don't get full value, but you get probably at least a good quarter, 5 out of 4 or 5 out of 4, 4 over 5 or 3 out of 4, whatever the questions were. But if you forget the negative from the set, you're not really understanding the setup, and that's kind of what's really important right now. Anyway, anyone have this thing worked out? 6 point something?
Negative 6.4.
Thanks. Negative 6.4 meters per second squared. Okay. So the acceleration is negative. Even when this object was traveling in the positive direction, the acceleration was still acting to slow it down, and then eventually it turned around and started going the other way. So think of it as running against the wind. You're running, wind blows, slows you down, stops, and starts blowing you the other way. All right. Stop.